Okay, here's a lesson for section 8.3, the surface area of prisms and pyramids. So for section 8.3, I divided it into two sections. One section on the surface area of prisms and pyramids, and one section on the volume of prisms and pyramids. So here's the section for surface area. Okay, well, what is the surface area of a prism or pyramid? Well, the surface area, I could probably write that better. Surface area of an object is the sum of the areas of its outside surfaces. So look at to find the surface area of an object, you need to figure out, okay, I need to find the area of each of the sides of that object and add them together. So another way to think about it is how much material is needed to build an object. Okay, so part one, let's find the surface area of a rectangular prism. So to find the surface area of a rectangular prism, I need to find the area of each of the sides of the rectangular prism, each of the outside surfaces, and then add them all together. So let's look at a rectangular prism that I've got here. Here's my rectangular prism. What I need to do, I need to figure out how do I find the area of each of the sides of that rectangular prism and then add them all together. Well, I've got my prism. I've labeled the dimensions length, width, and height of the prism. Okay, it doesn't really matter depending on your perspective which one you label the length, which one you label the width, which one you label the height. It doesn't really matter. Just it is important to label them so we don't get mixed up which dimension we use and how many times we use it, kind of thing. But for all intents and purposes, this could be your height. Oh, sorry. This could be your height. This could be your length, and this could be your width. That would be fine. Just make sure you label them so you don't mix up which ones to use how many times and so on. But okay, we label them length, width, and height. If I want to find the area of each of these sides, first thing you should notice is this side right here on the right side of this object is identical to the side on the other side, to that one. Okay. Well, what's the area of this side? It's a rectangle. To find the area of a rectangle, we do the length times the width, okay? And in this case, I've got the letters W and H labeling the length and the width. So to find the area of that, I would do W times H. But I know there's two of them. There's this one and this one. They're identical in area. So I'd have to do 2 times W times H. That's where I get this part of the formula for the surface area. So I'm taking care of that part of the formula. Now let's look at the bottom of this object. So I've got the bottom surface down here. To find the area of that, it's another rectangle, so I would do length times width, and the length and width are labeled with an L and a W. But I also notice the bottom of this prism is exactly the same as the top of this prism in area. So there's two of those, so just do 2 times L times W. That's where I get this part of the formula. And now let's look at lastly the front and the back of this object. So the front, I'll shade it in. Here's the front of the object. If I want to find the area of the front of this object, do length times width, because it's a rectangle. And the length and the width in this case are labeled with an L. And this part is labeled with an H. So I would do L times H to find the area of that part of the object. But what I want you to notice, the front is identical to the back of this object as well, so there's 2 of them. That's why I get 2 times L times H, and that takes care of this part of the formula. And then to find the surface area of that whole thing, just add all 3 of those things together. So 2 times L times W plus 2 times W times H plus 2 times L times H will take care of adding all of the areas of all 6 of the sides of a rectangular prism together. So let's practice one. If I want you to find the area, or the surface area, sorry, of this rectangular prism, what I need to do is find the area of each of the sides of this prism and add them together. We have a formula that takes care of that. The surface area, I'll use SA for short, of a rectangular prism is 2 times L times W plus 2 times L times H plus 2 times W times H. Okay? 2 times L times W plus 2 times L times H plus 2 times W times H. I have these reversed from our formula from above, but that doesn't matter. Okay? So what we want to do is label our rectangular prism, our length, our width, and our height of it. So I've got 3 dimensions. Doesn't matter, depending on your perspective, which one you label which. Just make sure you label them. L, W, and h. Make sure each of them get a different label. So I've got my length of my prism, or length of the rectangular base, width of the rectangular base, and the height of the prism. So what I need to do now, plug them into my formula. 2 times L times W, so 2 times 4 times 2, plus 2 times L times H, so 2 times 4, 2 times 4 times 1, plus 2 times W times H, 2 times 2 times 1. And let's figure this out. 2 times 4 times 2 gives me 16. Plus 2 times, so remember, order of operation tells you to do all the multiplication before any of the adding. So I've done this product, I've done the 2 times 4 times the 2, that gave me 16. 2 times 4 times 1 gives me 8, plus 2 times 2 times 1 gives me 4. Now I can do the adding. 16 plus 8 plus 4 gives me 28, and I'm in millimeters, and whenever you're doing in surface area, you're always in units squared. Okay, so 28 millimeters squared. Let's do another example. What is the total surface area of a room that has the following measurements? Well, what I have here is another rectangular prism. I know surface area of a rectangular prism is 2 times L times W plus 2 times L times H plus 2 times W times H. Okay, so all I have to do now, label my dimensions with L, W, and H. Doesn't matter which one gets which, just as long as each of them gets one of them. Now plug in what we have. 2 times L times W, so 2 times 3.4 times 4.2 plus 2 times L, 3.4 again, times H, which is 3.0, plus 2 times W times H, so 2 times 4.2 times 3. Now, let's do each of the products first. So I'm going to have 2 times 3.4 times 4.2, okay, 28.56. I won't round yet. I'll round when I get to my final answer to make sure it's as accurate as possible. Plus 2 times 3.4 times 3, I get 20.4. Plus 2 times 4.2 times 3. I get 25.2. Now that I've done all of my multiplication, order of operation tells me now I can do all of my adding. So 28.56 plus 20.4 plus 25.2, and I get 74.16. Now I'll round to the nearest tenth. I'll round to 74.2, and I'm in meters squared. Whenever you're doing a surface area, you're always in units squared, so meters squared. So 74.2 meters squared is the total surface area of that room. Okay, now let's do the surface area of a triangular prism. Okay, so this one's going to be a little more complicated, but not much. Still, what you want to do, you want to add the areas of all of the sides of the triangular prism together. So first of all, how many sides does a triangular prism have? Well, it's got a triangular base at one end, a triangular base at the other end. Those are two sides. And then what it has is 3 rectangles connecting those two bases. So what we have, 1, 2, and then 2 triangles, 3 rectangles. We have 5 sides. So to find the surface area of a triangular prism, we have to add the areas of all 5 sides. What I want you to note is, remember, a prism always has congruent bases, so the triangular ends are exactly equal in area. So there's no point in finding the area of each of them separately. Once you find the area of one of them, all you have to do is multiply that by 2, and that'll give you the area of both of them combined. So to find the surface area of the triangular prism, you have to find the area of the rectangles, so all 3 rectangles, and then add 2 times the area of the triangular base. Triangular base, because we know the triangular bases are congruent. Also, I should mention, depending on whether the triangular base is an isosceles triangle or an equilateral triangle or a scalene triangle, some of your rectangles may be equal in area as well. If you have a equilateral triangle, meaning all three sides of your triangular base are equal, then all three of your rectangles are going to be equal in area as well. So you could just do 3 times the area of one of the rectangles. If you have an isosceles triangle, meaning 2 sides of your triangular base are the same, then 2 of your rectangles are going to be equivalent in area. If you have a scalene triangle, however, if all 3 sides of your triangle are different, all 3 rectangles on the sides of your triangular prism are going to be different in area. So you'll have to find the area of each of them separately. Okay, so let's develop a formula for how we would find the surface area of a triangular prism, of this triangular prism. So what you want to always do, once you have your triangular prism, you want to look at the triangular base. You want to label the base of that triangle with a B, and then you want to label the other sides of the triangle. So this would be my B, and then label the other sides of your triangle with A and C. After that, you want to label the height of your prism, so the distance between the 2 bases, with an H, just like we did when we did volume of a triangular prism. And then you want to label the height of the triangular base with an L. So the actual height of the triangular base, label that with an L. Okay, now that we have all those labels taken care of, let's figure out how would I find the surface area of this entire prism. So how would I find the area of each of the sides and add them all together? And we'll get a formula for that. So the area of the triangular base. Why don't I find the area of a triangle? You have to do half times base times height. Half times base, and then I know I used to represent the letter I used to represent the height of the triangular base is not H, because H is the height of the prism. I used the letter L to represent the height of the triangular base. So half times B times L will get me the area of the triangular base. What I need to do now, so that gives me the area of the triangular base, and I know both of them are congruent, the triangular bases, so I don't have to worry about, so I've found out the area of this one. I know the area of this one is going to be exactly the same, so all I'll have to do is multiply that by 2 in the end, and I'll take care of that later. But now I need to figure, okay, how am I going to find the area of rectangle 1? Rectangle 1, let's make that the rectangle on the bottom. So this one that I'll shade in now. So we'll find the area of this rectangle. How do I find the area of that rectangle? Well, I know the area of a rectangle is length times width. The length and the width of this rectangle have been labeled with B and H. So the area of that rectangle is length times width, which is B times H. Okay, now let's do rectangle 2. Let me see if I can just delete this that I shaded in. Okay, good. I'll get rid of this too. Okay, now rectangle 2. I'll make that the rectangle on this side. If I want to find the area of this rectangle here, okay, what I have, I need to figure. I know the area of rectangle is length times width, so I need to figure what letters represent my length and my width. Well, I've got this letter A along this part of the rectangle. That's great, and then I know this side right here is going to be the same as this side, which the letter H is used for that. Okay, so the side lengths of this rectangle it's A by H. So to find the area of that rectangle, I have to do length times width, which I'll use the letters A and H to represent. So A times H will give me the area of that rectangle. Now let's get rid of all this stuff that I just drew. Now let's find the area of the rectangle on the other side. I'll try and shade it in so you can see it. Good. If I want to find the area of this rectangle, once again, the area of the rectangle is length times width, and the dimensions of this rectangle have been labeled for me. It's C by H. So to find the area of that rectangle, length times width would just be C times H. Okay, so I now have the area of each of the sides individually. If I want to find the total surface area, I have to do the area of the rectangles plus 2 times the area of the triangular base. So the area of the rectangles is B times H. I'm going to have to add A times H, and then I'm going to have to add C times H. Those are the 3 areas that I have for the rectangles. BH, AH, and CH. If I add all three of those together, that would give me all three areas of the rectangles. Now I have to add 2 times the area of the triangular base, plus 2 times the area of the triangular base, which was half, times B times L. Well, what I'm going to simplify here, I have 2 times a half. Well, what's half of 2? It's just 1. So essentially, those cancel out, and I just have 1 times B times L, which is just B times L. So to find the total surface area, what I have is B times H plus A times H, whoops, plus C times H plus B times L. So that's my formula for the surface area of a triangular prism. Now it doesn't matter which order you multiply these in. The B times L could be at the front, and I think in most formulas you see it will be. So I think I'll write that down here. I think B times L is usually at the front, plus B times H plus A times H plus C times H. And probably the A times H probably comes before the B times H in most cases. But like I said, it doesn't matter the order you add these together in. But it does matter which pairs are being multiplied together, okay? So make sure you have, make sure you're good at being able to label, you're able to label your triangular prism with the proper letters. And then just plugging into the formula will be easy. Okay, so label the base of your triangular base with a B, and then the other sides of your triangle with A and C, and then label the height of your prism with an H, and the height of your triangular base with an L. If you do all of those things with those 5 letters, you'll be good to go just plugging it into our formula here. Okay, I'm going to skip example 3 for now because example 4 is going to be a little bit easier, okay? Find the surface area of the following triangular prism. I'll make note of this later after we get going with our formula. So let's remember our formula for the surface area of a triangular prism. B times L plus B times H plus A times H plus C times H. Okay, that's the formula that we made right up here. B times L plus B times H plus A times H plus C times H. If you do those 4 things, add them together, you'll get the surface area of the triangular prism. All we have to do now, okay, let's label all of these numbers we have here, figure out which one is our ABC, which one is our L or H. So remember, start off, label the base of your triangular base with a B. So here it is here. Label the other 2 sides of your triangle with A and C. So this side right here, I'll label A, and this side right here, which is the same as this side right here, I'll label with a C. Let me just kind of try and delete these little lines I drew here. Okay, so I labeled this one with A, the other side's my triangle with A and C. Now I want to label the height of my prism with an H and the height of the triangular base with an L. Now just plug into your formula. So surface area equals B times L, so 3 times 3.6 plus B times H, so 3 times 3.5 plus A times H, so 3 times 3.5 again, plus C times H, which is 3 times 3.5 again. Now what I want you to notice here, since all 3 sides of the triangular base are equal, this triangle is 3 by 3 by 3. Since all 3 sides are exactly the same, we're going to have all 3 rectangle sides are going to be congruent. The area of all 3 of the rectangular sides are the same. Look, 3 times 3.5, 3 times 3.5, 3 times 3.5. Those are the 3 rectangular sides. All 3 of those are exactly the same. So what I could do, so I have 3 times 3.6 plus, there's 3 of these things. So just multiply that by 3. So 3 times 3.5 would be fine. I could do that if I wanted to, or you could evaluate them all separately. And I'll just do that for now, just so you can even further see how all 3 of the rectangles are the same. So the area of my triangular base is or the area of both of my triangular bases put together is 3 times 3.6, which is 10.8. Plus, now I'm going to add all three areas of my rectangular sides. So 3 times 3.5, that gives me 10.5. Plus 3 times 3.5 is 10.5 again. Plus 3 times 3.5 is 10.5 again. So all three rectangles are the same. And then what I have here is the area of both my triangular bases put together. Remember, the area of a triangle is half times base times height. Double that, 2 times a half is 1, so we're just left with base times height, which is 3 times 3.6. And remember, when I say height, when I'm talking about the area of the triangular base, I'm talking about the height of the triangle, not the height of the prism. Okay, let's add these together. 10.8 plus 10.5 plus 10.5 plus 10.5. I could have just done 3 times 10.5 if I wanted to. And I get 42.3. And what units I'm in? I'm in centimeters, and it'll be centimeters square. Okay. At risk of confusing you, I think I will go through this example. Because it's a right triangle, what's going to happen is one of the side lengths of the triangle is also going to be the height of the triangle, so one of the sides is going to be represented by 2 letters, but that's okay, we can do this one anyway. Hopefully that'll make sense as I explain it. So, find the surface area of the following triangular prism. So remember our formula, surface area equals, so I want to find the surface area of my triangular prism. I just used the formula I came up with before, b times L plus b times h plus a times h plus c times h. So, remember, start off, look at your triangular base. Label the base of that triangle with a b. So when I have a right triangle, the legs are your base and your height. Hopefully you remember that from our Pythagorean theorem section. The right triangle, the legs of your right triangle is the base and the height. The hypotenuse is neither the base or the height. Okay, so the legs of my right triangle, if this is my right triangle I'm looking at down here, okay, if this is my right triangle, these are my legs. The hypotenuse is this side over here across from the right angle. So those are going to be my base and my height. Okay, so I'll pick 13.4 to be my base. Doesn't really matter which one's your base, which one's your height. Okay, and then remember I told you after you've labeled the base of your triangular base, you then want to label the other two sides with A and C. So I'll label this side with an A, and this side here is the same as this one up here. So these two are the same. So I will label this one with a C. Next, label the height of your prism. So the height between, or the distance between the two bases, that's the height of your prism. Label that with an H. Next thing you want to do is actually label the height of your triangular base. And we use an L for that. So remember I told you that the legs are the base and the height? So I've labeled this leg the base. That means this leg has to be the height of the triangle base. So this is your A and your L. So the A and the L in this case are the same. Okay? So the height of your triangular base is one of the legs, and this is one of the legs, therefore that is the height of your triangular base. So that's your A and your L. So we're going to use 12 for A and L. So let's plug everything into our formula now. B times L, so 13.4 times 12. 13.4 times 12 plus B times H, 13.4 times 10 plus 13.4 times 10 plus A times H. Remember A is 12 as well. 12 times 10 plus C times H, which is 18 times 10. Okay, so let's do this now. Let's evaluate this. So I have 13.4 times 12. Remember to do all the multiplication before any of the adding because order of operations tells us to do that. 13.4 times 12 gives me 160.8 plus 13.4 times 10 gives me 134. 12 times 10 gives me 120 plus 18 times 10 gives me 180. Now add these together. 160.8 plus 134 plus 120 plus 180. That gives me 594.8. 0.8. And what units are we in? We're in centimeters, and we're dealing with surface area, so it's centimeters squared. And that's the surface area of that triangular prism. Last example I'm going to do is surface area. I'll do a pyramid after as well. Okay, we'll do surface area of a cylinder now. To find the surface area of a cylinder is made up of circular bases. Sorry, so there's a circle at either end, or circle at this end, or circle at this end. Okay, so that is our cylinder, which is a circular prism, if you want to think of it that way. So to find the surface area of this, I need to find the surface area of the circle at the top, and then multiply that by 2, because I know the circles at either end are identical. They have the same area. That's where the 2 times the area of the base comes in. Plus, I need to add the area of the lateral surface. So I need to figure out how to calculate the area of the surface around the outside of this. If you were to unwrap this cylinder, that surface is actually going to form a rectangle if you unwrap it. Okay? And this part, once it's unwrapped, is equal to whatever the height of the cylinder was. So that's going to be our h. And this part, the actual length of that rectangle, is going to be equal to whatever the circumference of this circle was. When we unwrap it, this part here is going to be equal to whatever the circumference of that circle was. And I know to find the circumference of a circle, you do 2 pi r or pi d, but we'll use 2 pi r for now. Okay. So to find the area of this rectangle, I do length times width, which is just multiplying this times width. This 2 pi r times h, which is 2 pi r h. So I should write that in here. Area is 2 pi r h. That's how I would find the area of that. Okay. Trying to delete this. I was trying to just delete this part. Let me do that. Okay. So that's where this formula comes from. The area of the lateral surface is 2 pi r h. That's where this comes from. And the area of the base is pi r squared, but there's 2 of them, so 2 pi r squared. That's where this formula comes from. Add those 2 things together, 2 pi r squared plus 2 pi r h. That gives you the surface area of a cylinder. So let's do an example. Let me get rid of all this stuff. Okay, so surface area of a cylinder equals 2 pi r squared. That gives me the area of both bases. The bases are circles. That's where the pi r squared comes from. There's 2 of them. That's why it's 2 pi r squared plus the area of the lateral surface, which is 2 pi r h. Now, all we have to do, figure out what we know about our cylinder. The only 2 variables we need to know are the radius and the height of the cylinder, and it gives us both. Here's the radius of the circular base, and here's the height of the cylinder. Plug in what we know. So 2 times pi times the radius squared, so times 3 squared, plus 2 times pi times the radius, 3 times the height, 4. I'm not sure why it's getting darker. Okay, now let's actually evaluate this. So that mass, the order of operation, tells me to do the exponents first, so I can do 3 squared first, which is 9, and then do the multiplication. So 2 times pi times 9 gives me 56.5486. 5486, 6, 7, and so on. I don't want to round yet. I want to keep as many decimal places as I can now and then try and round at the end. That way my answer is as accurate as possible. Plus 2 times pi times 3 times 4 gives me 75. Whoops. Gives me 75.398. 2, 2, 3, and so on. I'm not going to round yet. Now I need to actually add these 2 things together. So I'm going to add those 2 things together. And now I can round my final answer. I'll round to the nearest tenth. I get 131.9 if I round it to the nearest tenth. And I'm in feet squared. Now, let's do another example. So that'd be my final answer. That's the surface area of that cylinder. Let's find the surface area of this cylinder. So remember, surface area of a cylinder is equal to 2 pi r squared, that's a squared up there, plus 2 pi r h. Let's plug in what we know. It doesn't give me the radius, it gives me the diameter, but I know the radius is equal to half of that. So the radius is half the diameter, so 3.1. So essentially it does give me the radius. 2 times pi times 3.1 squared, and plus 2 times pi times the radius, which is 3.1, times the height. And here's the height. This is the height of the prism. So the height is 10. Okay, now if you're good at using your calculator, and if your calculator evaluates the order of operations in the correct order, you could just plug this whole thing at the same time, as long as your calculator will evaluate the exponent first, then the multiplications, and then add them together. So let's take a look at that. So if you type this all in at once, 2 times pi times 3.1 squared plus 2 times pi times 3.1 times 10, you should get 255.2 if I round to the nearest 10, and I'm in inches squared. Okay, if you're not going to do this all in one step, then what you should do, make sure you evaluate this first, then add them together. And make sure you evaluate the exponent before you do the multiplication, then do the multiplication before you do any adding. So make sure you follow your order of operations. Last example, I'm going to find the surface area of a pyramid, and more specifically, I'm going to find the surface area of a square-based pyramid. So a modern example of a pyramid can be found at the Louvre in Paris, France. The glass square-based pyramid was built as an entrance to this famous museum. Calculate the surface area of the pyramid, including the square base. Okay? So the surface area of anything, you need to add up the areas of the outside surfaces. So let's figure, what is a square-based pyramid made up of? Well, it's got a square base, so we're going to have to find the area of the base, which is a square. And I know a pyramid is made up of triangles for the other sides, which meet at the vertex. Since it's a square base, there's going to be 4 triangles. Okay, so I have to find the area of each of those triangles, and each of those triangles are going to be the same. Because the bases are all going to be the same length, because each of the sides of the base are the sides of the square, which are all the same length. So I just have to find the area of one of the triangles and multiply it by 4. So essentially what I'm doing, I find the area of the base, so the area of the square, and adding 4 times the area of the triangle, because there's 4 triangles that are identical that make up this pyramid. So I just put a note, this formula only works for a pyramid with a square base. If it had a rectangular base, you would need to find the area of each. 2 pairs of triangles will be equivalent. Or if it was a triangular pyramid, each of the triangular sides may be different. So just be careful when you're finding the surface area of anything. Make sure you carefully analyze. Make sure you just carefully analyze what shape you're looking at, and learn how to figure out the area of each of the sides and then add them together. In this case, I'm going to find the area of my base. So I'll start by doing that. Area of my base equals. It's a square base, so I know the length and the width are both 35. So length times width is 35 times 35, which is 35 squared, plus 4 times the area of the triangle. So the area of the triangular sides is half times base times height. So 4 times half. The base of the triangular side is 35, it gives that to me, and the height of the triangular side is 27.8. Half times 35 times, what does this say up here? 27.8. Okay, let's evaluate this, and that'll tell me the surface area of the whole object. So I'm going to do 35 squared. That gives me 1225 plus 4 times a half. Well, what's half of 4? It's 2. So 2 times 35 times 27.8. That gives me 1946. Add these two together. I'm following the correct order of operations. I did my multiplications before I did the adding. So add 1225 to the 1946 I had, and I get 3,171. And what units am I in? I'm in meters and it'll be meters squared. Meters squared because I'm working with area. So that's the surface area of that square-based pyramid. So make sure you've gone to jensenmath.ca, you've got the worksheet, you can try it out now, and let me know if you have any questions. Just make sure if you find the surface area of any shape, any three-dimensional shape, just find the area of each of the sides and add them together.